going to just find one term. So we did that yesterday. Let's see what we remember about that. We are ready for 2b on the back page 58. We're ready for 2b, which says we have x minus y to the 10th, and we want to find the coefficient of the x to the 4th, y to the 6th term. So you know enough about this to know that if I multiplied that thing out, the first term would have x to the 10th, and then there'd be a term that had x to the 9th and x to the 8th and so on. So eventually in the list, we'll get down to an x to the 4th. And of course, if it's x to the 4th, it has to be y to the 6th, because the powers will, these powers will always add up to that. Okay? So our job is just to figure out, all right, what number, when I write out all these terms, what number would be attached to that x to the 4th? Well, we know that when we do the expansion, the numbers come from Pascal's triangle. But I don't want to do Pascal's triangle for this problem because I would have to go all the way to the 10th row, which I can do. You always have that option, but it takes a long time and a big space. So yesterday, right at the end, we made the connection why we're even doing this in this chapter. Because we observed that the numbers in the 10th row are the 10C numbers. So the 10th row would start with 10C10. And then it would go to 10C9 and 10C8 and 10C7 and so on. I don't want to write them all out there. Those are the coefficients. I don't want all of those. There's no need for me to write them all out. I only want the one that's on the x to the 4th. So remember, in this first term, the one that has 10C10, wouldn't this have the x to the 10th?
Yep.
And this one would have the x to the 9th? So which one is going to have the x to the 4th? What is going to be the 10C number?
10C4.
10C4, sure. Now before you get all confused, look, when it was 10C10, it was x to the 10th. When it was 10C9, it was x to the 9th. We're counting down these numbers just like we're counting down those numbers. So that coefficient is 10C4. Now, you do have to be careful. What is 10C4?
210.
What is it?
210.
210. So 210, next to the 210 would be an x and a negative y. And this is why you have to be careful. It isn't going to matter in this problem because that's a 4 and that's a 6. What's going to happen to that negative? Since it's to the 6th power, it will go away. But if that had been a 5, then I would have to make sure I put a negative out here, right? You see what I'm saying? There's a negative in this problem. It doesn't matter this time because we're taking it to the 6th power, so it's gone. So what was the coefficient? 210. That's your coefficient, 200. You feel okay about that? All right, find the third term of 2x plus 3y to the 5th. Now, every term has 3 parts to it. It has a coefficient. It has, in this case, a 2x and a 3y. Every single term for this problem will have that. A coefficient, some power of 2x, and some power of 3y. We want the third term. Now, this is only to the 5th power. So if you still have Pascal's triangle written on your written on your paper, you know the fifth row of the triangle is this. So you have that. If you don't have that, third term gonna be 10. If you don't have that, then you can remember that the first number is 5C5. We're in the fifth row. The second number is 5C4, and the third number is 5C3.
How do you know it's the third term on that one?
It says, find the third term.
Oh, that probably makes sense.
Now, if you type 5C3 in on your calculator, guess what you're gonna get?
That's it.
10. So I can use Pascal's triangle, because that's not a very big number, or I can do what I did over here and use my C numbers. What's the matter, Nolan? You're making a face at me.
Nothing.
He doesn't believe 5C3 is 10, so he's gonna type it in and make sure.
Oh, cause
Now, what else do I need? I have my coefficient, whether I got it from the triangle or from the combination numbers, I've got my coefficient. I know I've got a 2x and a 3y. What's missing? What's missing? I did, right. You want to need some exponents? You want to need some exponents? In the first term, right here, the exponent on 2x would be 5. In the second term, it would be 4. And in the term I want, the exponent on the 2x is going to be 3. It's not 3 because it's the third term. It's 3 because when I counted down, that's what I got. 5, 4, 3. And of course, if that's a 3, that's a 2, because they have to add up to 5. We good? Now we gotta simplify. And this is where if you're not careful, you can mess it up. What is 2x cubed? 8x cubed. Good. What is 3y squared? 9y squared. Now I multiply all that together. So 10 times 9, 8, 10 times 8 times 9 is 720. And then I have my x cubed and y squared. So the question said, what is the third term? That is the third term. Okay? All right, number 3, evaluate by hand. You're probably wondering, well, probably not, but you should wonder, Ms. Ford, when you took this class, when you learned all this material back 50 years ago, how in the heck did you do all this without a calculator? Well, all of this stuff can be done by hand, and I'm going to show you how it's done by hand. Evaluate by hand. This notation means this. So that's the first thing you have to know. When you have like a big parentheses and numbers written vertically like that, that's a combination. You could type that in on your calculator, 7C3, and get whatever it is. The formula for 7C3 is 7 factorial over 4 factorial, 3 factorial. Now, I bet you see where the 7 came from, 7 factorial. Maybe you can see where the 3 came from. Where'd that 4 come from? The difference, exactly, exactly. So it's this number over this number and the difference. So there's 2 things in the denominator. The difference, 7 minus 3, 4, and that number. still terrible, Mrs. Ford. How did you do this without a calculator? Well, it's not bad at all. What does 7 factorial mean? 7 times 6 times 5 times 4 times 3 times 2 times 1, right? What does 4 factorial mean? 4 times 3 times 2 times 1. Wait a second, won't all that cancel with all that? And then 3 factorial is 3 times 2 times 1. 3 times 2 times 1 is just 6. So what's the answer to the problem? 35. 35. So if you typed in on your calculator 7C3, it will say 35, but this is how you do it with the formula instead of just pressing the button. So, can you do 8C3 for me? Not on the calculator. Can you do 8C3? What's the formula say? Numerator is 8 factorial. Denominator is 5 and 3, and those can be in either order, doesn't matter. Everybody okay with that? Now, if we're doing this without our calculator, we'll have 8 factorial, oops, it's in order. Over everybody look at that and make sure that makes sense to you. From 5 on is gonna cancel. Three times 2 times 1 is just 6. So 8C3 is 56. See how easy that is? Yep, easy, easy. All right. C, ooh, these are big numbers. So remember, that notation, which we've not used before, that notation is 100C98. Wow. What's the formula for that?
100 factorial.
That's gonna be 100 factorial over 2 factorial, 98 factorial. Wow. Man, oh man, I do not wanna write this out. But you don't have to. You don't have to, because look what happens. Once I get down to 5, doesn't everything from 5 on cancel out? So if you think about this, 100 factorial is 100 times 99 times 98, right? I'm gonna divide that by 98, 97, Isn't all of that gonna cancel with all of that? So you don't need to write it out, because it's all gonna cancel. All you have left is 100 times 99 divided by 2, which is 50 times 99. You can type that in on your calculator. But that'll be the answer. So what is that? 50 times 99.
Show you what he said. 4,950.
I know, I should be able to get my head. 4,950. Thank you. Kaden, do you need to go see the nurse, sweetie? No. All right, one more. Oh, there's a couple more, I guess, on the next page. All right, let's do 11C6. So start with your formula. What is your formula for 11C6? factorial over 6 factorial, 5 factorial. Now you are welcome to write out all of this. So if you want to write out everything, that is okay. But I'm not going to, because I know that everything from 6 on is going to cancel. I always cancel my biggest one. So everything from 6 on is going to cancel. Would you agree with that? So I am left with this over the 5 factorial. Everybody okay? Now, I can start canceling. Remember, there weren't any calculators, so I can start canceling. So 5 times 2 is 10. 4 goes into 8 twice. And 3 goes into 9 3 times. So the denominator is gone, and all I have left is this. Now, I'm going to let you do that on your calculator, but you have to admit that's not bad. I can do that arithmetic. In the old days, I had to do that arithmetic. I can do it. It's much easier than all this, for sure. So what is that?
462.
All right, now you do E, 10C7. You do that one. 10C7, let's see. Don't just type it in your calculator. Work it out longhand. What's your formula? What did you start with? 10 factorial over what? 7 factorial, 3 factorial? So we have 10, 9, 8, 7 over 7 times 3 times 2 times 1. So everything from the 7's on is gone. 3 goes into 9, 2 goes into 8. Did you get 120? What's your answer? Pretty easy.
Wait, never mind. It was a dumb question.
You got it figured out?
Yeah.
Okay. All right, now look at F. What is different about F? F is a P. P's have a different formula, so you're going to have to keep this straight. 10P2 is 10 factorial over 8 factorial. What's the difference? Well, the C's have 2 numbers in the denominator. The C's have that number. And the difference, the P's only have the difference. All right, so dash that up there. The P's only have the difference. So, isn't this just going to be 10 times 9? Because after the 8, it all cancels with the denominator. So the answer is 90. All right, AP5. This one's gonna be a little bit bigger. What's our formula for AP5? 8 factorial over 3 factorial, just the difference. Remember, the P's are over just the difference. That's one thing to remember. So this one's gonna be a lot. It's gonna be 8 times 7 times 6 times 5 times 4. Can I stop at 4? Because the 3, 2, 1 will go away with that. That's a lot. I don't know what, you can type that in on your calculator. That's a lot to multiply. What is that?
6,720.
What?
6,720.
6,700. We good with that? All right, 9-2 is due on, what is it, Thursday, Monday? 9-2 is due on Monday. All right, and now we're gonna start 9-3, which is probability. So those of you that are dying to do some card problems, this is it. We're gonna be doing a few card problems along with some other kinds of problems. Okay, so here we go. Who can tell me what probability is? When I say the word probability, who can even tell me what that equals? Well, it can be expressed as a percentage. You can say there's a 20% probability. It can also be expressed as a fraction. We can say there is a 1 in 5, 1/5 probability. So that is absolutely true. What if let's just do an example, maybe you can tell me what the definition is. If I roll a die, 6-sided thing, I roll that thing. What's the probability that I will get a 4? 1 in 6. Okay, now how did you arrive at 1/6? Probability is going to be a fraction, which I could write as a decimal or a percent. How did you get 1/6? What's the 1? That was what we call our successful outcome. We wanted to get a 4. There's only one 4 on the thing, so there is one successful outcome. So up here, we're going to put the number of successful outcomes. That is what we want. A successful outcome is what you want. So if I say the probability of guessing a true-false question correctly is 1/2, that 1 means there's one right answer. Right? Now you said 1/6. Where did the 6 come from when we rolled that die? Possibilities. So it's the number of possible outcomes. Sometimes we call that the total. There's 6 possible outcomes, so 6 total outcomes that could happen. Now, while we're at it, we're going to make the distinction between probability and odds. Especially if you watch horse racing, they'll talk about the odds of a horse winning. Does anyone know the difference between probability and odds? They aren't the same. A lot of people use them interchangeably and they're not the same. Anybody know the difference?
So like if the horse had like a 1 out of 5 odds to win, that's not the same as there being like, sorry, I'm mixing my words up.
Okay.
Yeah, it's probability and odds aren't the same because like if there's a 2 out of 5 odds for that horse to win, there's not literally 2 horses running, like,
Okay, so yeah, so that can be, yeah, I understand what you're saying there. That can be a product of the fractions being reduced though. Here's the difference. When you told me, I got my die, I'm gonna roll it, the probability of getting a 4 was 1/6. You are correct. The odds of getting a 4 are 1/5 because odds are the number of successes over the number of failures. So when we say the odds are 2 to 5, and odds are often written sideways with a colon, when we say the odds are 2 to 5, that means if we played the game or ran the race or did whatever, if we did it 7 times, we would win 2 and lose 5. This is winning, this is good, this is bad, this is success, this is failure. Probability is success over total. So if the odds are 2 to 5, the probability would be 2/7. Because 2 successes, 5 failures means 7 total. And 2 of them are successful. Okay, so one more time. Probability is what you want over the total. Odds are what you want over what you don't want. When someone says the odds are 1 to 1, that means your chance of winning is exactly the same as your chance of losing. 1 to 1. Probability is 1/2. They're called even odds. 1 to 1. All right, let's do some problems now that we've got our definitions taken care of. All right, problem number 1. And some of this is going to seem so easy. I want it to. I hope it does. And some of it's going to get a little bit more complicated as we move through. All right, so Maggie has a bag of M&Ms and Elizabeth has a bag of M&Ms. Each girl has counted and sorted for M&Ms so she can see Maggie, for example, 30%, 30% of Maggie's M&Ms are green. 20% are yellow, and so on. You see how to read the chart? So in other words, if Maggie reaches into her bag of M&Ms, she has a 30% chance of getting a green one. All right, so here we go. If a candy is chosen, this is problem A. If a candy is chosen from Elizabeth's bag, what is the probability that it will be green? Elizabeth.
1 out of 5.
So I would say 0.2, but that's the same as 20%. And if you want to go with a fraction, that's 1/5. Those would all be correct answers. In Elizabeth's bag, 20% of them are green. How about Maggie's bag? What is the probability it will not be yellow? Read the question. Now we're over here in Maggie's bag. Probability it will not be yellow. What do you think?
70%.
4 over 5.
I would say 0.8, but that is the same as 80%, which is the same as 4/5. In Maggie's bag, not yellow means everything except yellow, right? If yellow is 0.2, then isn't everything else 0.8?
Is there something rather than
Nope. And when they're written as decimals, Abby, it seems, let's just use the decimals. But It's the same as a percentage and it's the same as a fraction, it doesn't make any difference. If a candy is chosen from each bag, what is the probability they will both be red? What is Maggie's red? Maggie's red is 0.2. What is Elizabeth's red? 0.3. Now, keep in mind, we're getting red and red. And if you've been really listening carefully, you've heard me say a couple of times that when we're doing this and this, what operation do we use? Multiply. Multiply. When do we use addition? Or it doesn't say get a red or a red, it says I gotta get both red. So red and red. Now, be careful, you will always have a calculator when you do this. There's no reason to miss this problem. This is not 0.6. This is 0.06. Right? So let's type it in correctly. If we can't do it in our head, which is fine, type it in. Don't just take a guess and guess wrong. All right. If a candy is chosen from each bag, what is the probability that neither will be brown? So that means not brown and not brown. So what's the probability that Maggie is not brown? 0.8. What is the probability that Elizabeth is not brown? 0.9. And what do we do with those two? Multiply them. So your answer is 0.72. Candy is chosen from each bag. What is the probability that the first one will be green? So I want green. And the second one will be blue. All right, so that's Maggie is green, Elizabeth is blue. All right, so we get Maggie is green. So what's the probability Maggie's green? 0.3. And then I need Elizabeth to be blue. Elizabeth to be blue, actually be blue. 0.2. And since it's green and blue, I will multiply those. And the answer is 0.06. F, oh my gosh, what's the difference with F? F looks like the same question. I want blue and green.
It's just switched.
E says the first one, F says that one maybe.
So what again, Trick?
E says that the first one will be green, and then the F says that what is the probability that one will be green?
Exactly. So what does that mean? That means that I could get green, or excuse me, blue and green, or I could get green and then blue. Read the questions carefully. E, doesn't E stipulate I have to get this and then I have to get this? F just says I want one of each. And I don't care what comes out of what bag, I just need one of each. So I have to do both of these problems. So Maggie blue would be 0.1, and Elizabeth green would be 0.2. So that's 0.02 when I multiply them together. So that's my probability of getting a blue one and then a green one. Now, I need green from Maggie. in blue from Elizabeth, that's 0.06. In problem E, they told me what order to go in. In problem F, they didn't, so I had to look at both orders. Now, what am I gonna do with these two numbers? I'm gonna add them. Absolutely, I'm gonna add them. When it's this and this, I multiply. When it's this or this, I add. So the answer to that problem is 0.08. Last one of this kind. If candy is chosen from each bag, what is the probability that neither will be red? So I want not red and not red. Neither is red. So no reds. Well, what's Maggie's not red probability? 0.8. And what's Elizabeth's not red probability? So the answer is 0.56. Is that okay? All right, turn the page. Consider being dealt a 5-card hand from a standard deck. Now, are we all familiar with a deck of cards? So there are 52 cards in the deck. We are not going to do any weird games with weird rules and weird decks and all that. We're going to use a standard deck of cards. So we have 52 cards. Now, what can you tell me about that deck of cards? It's split up into 4 suits. And the suits are diamonds, clubs, spades, and hearts, right? And if there's 52 altogether, and you're splitting it up into 4 kinds, then there's 13 of each. So there's 13 hearts in the deck. Hearts and diamonds are red, and clubs and spades are black. So half the deck is red and half the deck is black. Right? And then within the suit, so if we just look at the diamonds, there are 13 diamonds, and what do they look like? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. And those 3 cards, Jack, Queen, King, are people. They're called face cards because the cards have a face on them. So there are 3 face cards in each suit. All right, these are basics you need to know to be able to do these problems. So if you're uncomfortable with that, Google it, spend some time with a deck of cards. I can even bring some in, I guess, if you want to come in office hours and look at the deck of cards. But you have to know those basics in order to do these problems. Okay, so here we go. Number 1, you're going to be dealt a 5-card hand from a standard deck. How many 5-card hands are possible? How many cards are in the deck?
52.
So right here, 52 cards are in my deck. I am going to reach in and grab how many of them? 5. Does the order that I choose them matter?
No.
52C5. That's how many hands are possible. Now, when you type that in on your calculator, you're going to get a very large number. 60 different 5-card hands are possible. All right. Let's hear your thoughts on question B. What is the probability of being dealt a hand with all diamonds? So in other words, we want all diamonds over the total. Now guys, you already know the total. Isn't that the total? So your denominator is gonna be that number, which I don't wanna write that number, so I'm gonna write 52C5, but that is the number. That's your denominator. That is the total number of hands, 5-card hands. Now, my numerator, I want all diamonds. Okay, so think about that for a minute. I've split my deck up. How many cards are here? This is a diamond pile. How many are in the diamond pile? 13. How many of those do I want? 5. So my numerator is going to be 13C5. Do not ever think you can cancel. You can cancel in a factorial problem. You cannot cancel here. All right, nothing cancels here. You think that's going to be a big probability or a little probability? Okay, very little. Here we go. 13C5 divided by 52. C5. 4.95 times 10 to the negative 4th. Notice when you type that in, you got an E at the end. That's E to the negative 4th, that's 10 to the negative 4th. So that number is 0.000495. So your probability of being dealt all diamonds is about 0.04%. Very, very, very small number. Don't bet your allowance on it. Very small number. Okay. All face cards. What is the probability of being dealt a hand with all face cards? Okay, last one we're going to do today. Hang in there. What's your denominator going to be? 52C5. Anytime you're doing a 5-card hand, that's your denominator, because that's the total. Now I want all face cards. So I've separated my deck. Here's my pile of face cards. How many face cards are there? 12. 3 in each suit. So 12. So your numerator is 12C5. This is going to be an even smaller number. .05 times 10 to the negative 4th. So you can leave it like that, or you can convert it to standard notation, which is that. Remember, 10 to the negative 4th means move the decimal point 4 places. And we will stop there. So you've got some homework done or to do. How did we do on our quiz? Do you feel like we did well? Yeah? Love it?